Great. So hope you are all having a fantastic week reinventing with AWS. Really a lot of exciting innovation going on out here in Vegas. Thank you so much for spending 1 hour here with us today, Thursday on Mandalay Bay. I know it's a little bit of commute from other venues, so really appreciate your attendance. So welcome to our session, a deep dive into Amazon Elastic File System. My name is Yufi Zhang. I'm a senior product manager on EFS team. I'm joined here today with Alex Martino.
Hi.
So before we go into today's presentation, we have a nice packed room for 1 p.m. on Thursday. So I'd love to hear from you, like who here has set up and managed their own file system before? Raise your hand. Okay, I see a few hands. So you must be understanding all the operational burdens of configuring and maintaining your own servers and storage infrastructures, and especially scaling up that infrastructure to accommodate for your growth. Okay, next, who here have ever used EFS, familiar with our product and service? All right, nice. So that's great. You are already in better hands. I hope you are benefiting from the simplicity and elasticity our team strive to deliver to you guys. And really quick today, we hope all of you here can take home with a few key points. So the first one is that EFS will provide a simple cloud file storage that just works, allowing you to take storage off your mind and focusing only on solving a business problem. And second, EFS offer a really rich feature set that can help you automatically achieve performance, save cost, and ensure security. And thirdly, most importantly, we'll demonstrate what we have said with a live demo at the end. All right, let's dive in. So first, let's starting from why EFS. Amazon Elastic File System is a serverless, fully elastic file storage that's designed to provide the 4 points that you can see above. The first one is that it's configuration-free, which means you can set up a highly available, durable, and secure file system in just a few clicks without any complex settings. And it's a fully elastic storage so that you can scale to exabytes on demand without disrupting your application. And imagine the tons of servers that you would need to stand up by yourself to support its capacity. EFS will allow you to share file data without managing storage infrastructure and provision performance. And third, it is accessible from anywhere. It's compatible with all types of AWS compute and also on-premises resources. And fourth, it offers pay-as-you-go pricing model and all the built-in features to help you automatically optimize cost based on your data access pattern. So let's look into each of them one by one. Starting from the integrations. So AWS offers a spectrum of compute services for application modernization based on what the customer wants to manage. And Amazon EFS will provide full AWS compute integrations. So you can start from the very bottom with EC2 and have access to all the knobs that you want to manage by yourself. Or you could go completely serverless with Lambda, where you're only focusing on building your own applications and let AWS manage everything else for you. And this is super empowering because your team has the choice to pick the layer of abstractions they're most comfortable with. And depending on your selection, AWS will provide you with necessary toolings, services, and APIs to help you build your application. And Amazon EFS just works for all types of this compute and available to you with AWS. So EFS can be shared with up to tens of thousands of concurrent clients, no matter the type. So this could be traditional EC2 servers, containers running one of your self-managed cluster, or one of the AWS container services like Elastic Container Service, ECS, and Elastic Kubernetes Service, EKS, and Fargate. Or in a serverless function running in AWS Lambda. So our customers can use EFS for a shared persistent storage to build stateful applications. So customer can also use EFS with AWS machine learning platform, AWS SageMaker. And you can also access your EFS file system from on-premises using AWS Direct Connect and AWS VPN. So now let's talk about application modernization, which is on top of mind for many of our audience here. So customers usually follow a path to modernize their applications by taking the existing applications that are on-premises running on an EC2 instance and moving them into containers, serverless, and microservice-based architectures to simplify their deployment of operations. So when we talk to customer about moving and growing in the cloud, with EFS especially, there are really two things that excite them. The first one is how easy it is to get started. As we mentioned before, EFS is completely serverless, and you don't need to provision or manage any storage infrastructure or capacity for your file storage. And beside that, customers are also really excited about how EFS can help them minimize the risk alongside their cloud journey. It's super easy to just lift and shift the application and onto EFS with minimal disruptions on your application. So if you're already running a application backed by NFS network file storage today, EFS can provide you with the same type of interface that your application developers and users are already used to. So because of the native integration between EFS and both Amazon ECS and EKS, applications that need either shared or persistent storage can be easily migrated to AWS. And EFS provides shared access to files from all nodes in a container cluster, enabling a lot of capabilities, including persistent volume for stateful containers, faster restores of containers in the event of a crash, and faster application scaling so that it can quickly launch a new container as application demand grows, or to enable self-service provision models. So with EFS, customers can persistent storage across containers. You can pay for what you use, and you can create and manage multi-tenant environment in a cloud-native way using AWS IAM authorization and access points. So to make it even easier for developers to use EFS with Kubernetes services, we've also released a EFS container storage interface driver, which we call a CSI driver. So this is available as an open source project on GitHub. So if a container is rescheduled onto a new node, the CSI driver will make sure that the volume is available and connected when it restarts, so it can eliminate all the manual provisioning of the file system. Beside all these computing services, EFS is also integrated with many other native AWS services, including AWS IAM for access control, AWS KMS for security, AWS CloudWatch and AWS Cloud Trial for monitoring, and also AWS Data Sync for faster migration, and AWS Backup for additional data protection. We also have integrated EFS with AWS System Manager to simplify management of the EFS clients. To summarize, EFS is a natural fit for file storage for customers' modern application in the AWS ecosystem. And EFS just works and make it really easy for you to lift and shift your application and start growing in the cloud. So in the next section, I want to shift the gear to talk about what's on top of mind for our storage customers, performance. Now, EFS provides 3 throughput modes. As you can see from the chart above, you have the flexibility to choose what works best for your application and workloads. So starting again with what they are, the first one is elastic throughput, which we call it ET. So ET is usually the best throughput mode for most workloads that provide the simplest experience and highest throughput scalability. And second, we have PT, provision throughput mode, which is best for those workloads that require higher or consistent throughput. This can provide you with consistent billing and predictable billing. And third, we have bursting throughput mode, which is good for workloads with basic throughput needs. And bursting throughput mode is tied with the storage in your file system in a form of bursting credits, and it can scale automatically as your file system size grows. So as many workloads currently are spiky in nature, so elastic throughput mode is the default and recommended throughput mode for most workloads. A little bit more on elastic throughput mode, which I'm really excited about. This is what we launched at re:Invent 2022, 2 years ago, and this is a throughput mode that automatically scales performance to meet your application requirements. So if you have a spiky workload, like in this chart, on average, it has a low throughput requirements and can experience unpredictable performance peaks. For example, if you have a e-commerce platform with the recent like Black Friday traffic, or if you have a machine learning or analytic use case. So elastic throughput is designed for your workload. How it works is that as a multi-tenant file system, so EFS will give you access to the performance of tens of thousands of servers without provisioning or fixed costs. So it allows you to scale up on demand your performance, and you can benefit from the resources of the entire group whenever you need it. To recap, customers should start with default elastic throughput mode if you don't know or if you are unsure about your performance needs, or if your workload is spiky and unpredictable in nature. To better understand your workload pattern, you can keep an eye on CloudWatch metrics to determine your workload's average to peak ratio. Elastic throughput mode is good for your application if your application is driving an average to peak ratio of 5% or less. You can use provision throughput mode if you know your workload's performance requirements, or when your application drives higher level of throughput consistently, for example, at an average to peak ratio of 5% or more. And at the end, you can use bursting throughput mode when you want your throughput that scales with the amount of storage in your file system. So it can allow you to burst to a higher level of throughput for a short period of time. But one thing to keep in mind is that bursting throughput mode has lower throughput upper bound. So after using bursting throughput mode, if you find your application is maybe performance constrained, for example, it uses more than 80% of the permitted throughput to your file system, or it's running out all the burst credit available to you, you should maybe consider switching to either PT or ET for higher throughput limits. Now let's look at some numbers. We are continuously committed to improving performance for all type of workloads on EFS. And in 2024, we had 5 performance improvements launches that increased EFS performance scalability by over 10x across different performance dimensions, covering throughput, per client throughput, and IOPS. So here is a performance summary of EFS today. As you can see, we now support at re:Invent 2024 60 gigabytes per second for read throughput and 5 gigabytes per second for write throughput. We support 1.5 gigabytes per second for per client throughput, and we support up to 2.5 million read IOPS and 500,000 write IOPS. This is really impressive enhancement that I'm really proud of our team working really hard for delivering the past 2 years. That said, if you haven't tested EFS recently, we really recommend you to give it a try. All right, the next topic I want to cover is cost. And how EFS will help you lower your TCO, total cost of ownership, with some of our built-in features. So EFS offers 3 storage classes, including EFS Standard, EFS Infrequent Access, and EFS Archive. So EFS Standard is the SSD storage class that provides you with sub-millisecond latencies for your active frequent access to data. And EFS Infrequent Access and EFS Archive provides you lower cost compared with EFS Standard for your coder data. Specifically, EFS Archive, which we launched at re:Invent last year, is a cost-optimized new storage class for long-lived file data that is accessed a few times a year or less. And as you can see, IA storage class provide 95% lower cost than standard, and archive storage class provide 50% lower cost than IA. So together with the 3 storage classes, we have 2 features called EFS Intelligent Tiering and EFS Lifecycle Management, which monitors access pattern of your file system and move file across 3 different storage classes automatically. So when needed, all your data across the 3 tiers is accessible from a single file system that is automatically cost optimized for a mix of active and inactive data based on your own access pattern. Let's take a closer look at Amazon EFS Lifecycle Management. So once set up, any file that are not accessed per a lifecycle management policy, this policy can be set up to from 1 day, 7 day, 14 day, up to 90 days. So those files are not accessed in this policy period of time are automatically moved from EFS standard into their corresponding infrequent access tier or archive tier. And the data remains in the file system and is accessible to end users and applications, but they're just stored at a much cheaper price. And this is EFS intelligent tiering. This delivers automatically saving for workloads with changing access pattern by placing your file data in the appropriate storage class at the right time. So when the data set has been sitting cold for months, suddenly become hot again, it can be transitioned automatically back to standard. And then you can benefit again from the sub-millisecond latency and the performance, all the SSD performance standard class can deliver to you. So example including maybe you are running a large model financial backtest with your data has been sitting doormat for a couple months. With intelligent tiering, after first access, this data will be transitioned back to standard and can be accessed with the SSD latencies again. So EFS intelligent tier is designed to help you achieve the right place for your file data at the right time and to help you achieve the right performance and cost without having to manually move data around. All right, in summary, so EFS is designed to help you optimize cost automatically. So you can significantly lower your TCO by using EFS because first, there is no minimum commitment or fees. You only pay for what you use. Second, it provides you flexibility in throughput mode and offer you cost-optimized performance per unit cost. And thirdly, it is optimized to be consumed with any AWS compute model at scale. And by the way, I want to call out that the multi-AZ architecture also enabled use with compute running any AZ without you having to worry about cross-AZ charges. And it also offers cost-optimized storage class, intelligent tiers, and also automatic lifecycle management to lower cost of storage. And if you are going to do a total cost of ownership analysis, compare this running to your own file system, storage infrastructure, what you will find is that EFS is 90% more cost-effective than doing it yourself. Another important aspect for storage is availability, durability, and data protection. So let's take a look into this. EFS is highly available and designed to be highly durable. So it offers 99.99% availability SLA, and also we are designed for 11 nines data durability. So to achieve this level of availability and durability, all files and directories are on the back end redundantly stored within and across multiple availability zones, or AZs. It means that when you write data to Amazon EFS, for example, the write itself is not acknowledged until the data is durably written across 3 availability zones. And EFS file system can withstand the full loss of a single AZ while still providing you the same quality of service in another AZ. So taking a step further, you can also back up your EFS file system with AWS Backup. This will again protect your data by storing in 3 availability zones and is completely independent software stack. This will give you the diversity in both physical infrastructure and also software implementation. For additional data protections, we have natively integrated EFS with AWS Backup, as we mentioned. For example, you can protect your file system's data from accidental deletion by a user or an unwanted overwrite by application. And you can back up your file system in just a few simple clicks in the EFS console or make a simple EFS API call. So we have also a new feature for EFS replication, which I'll get into. EFS native replication feature will allow you to easily maintain an up-to-date replica of your file system within the same or across AWS regions. Or you can replicate to a new file system or an existing file system. You can replicate in the same AWS account, or you can replicate to a new or separate AWS account. So replication is async, and it allows for minutes of RTO and RPO. So at re:Invent 2023, we launched the replication fallback, which allows you to switch the direction of a replication configuration between the primary and the secondary file system. So EFS replication will keep the 2 file systems in sync by only copying the incremental change. So you don't need to copy in the whole file system on the event of a disaster recovery fallback. So prior to re:Invent this year, just a few weeks before, we launched a cross-account replication feature, which will enable you to automatically keep replica of your file data in a separate AWS account. So all these features eliminate the need for setting up your own customized access to synchronize your EFS data across regions and accounts, and this really enhances the resiliency and reliability in a highly distributed environment. I know it's already a lot, but last but not least, let's talk about security, which is also very important. So there are really two fundamental goals in terms of identity and privacy when applications are accessed by shared storage. The first one is the storage needs to only be accessible from a certain set of clients. And the second, those applications, those clients need to be presented the proper credential and permissions to access a specific piece of data. So we have two features here I want to call out, which can help you maintain security while managing your application access. The first one is EFS access points, which will give you a really simple mechanism for providing application-specific entry points into your file system and data. With access points, you can synchronize permissions and prevent privilege escalation by enforcing the identity of all inbound connection using that access point. And this is particularly useful in a serverless function where there is no first-class notion of POSIX identity. And we also recommend you to use AWS Identity and Access Management, IAM, together with EFS, where you can attach the policy to your file system that is governing its usage. So put together, you can limit which user can use which access point and with which permissions. So some of the best practice for security to end my part. First, always control application access to your file system. Use AWS IAM policy and EFS access point. Second, always control network access to your file system using VPC security group rules. So a security group rules act as a firewall, and all the rules that you add defines the traffic flow. So you can specify security group rules for your EC2 instance and also for your EFS mount targets. And at the end, we recommend you to always enable encryption in transit and encryption at rest. So you can do that by using the EFS mount helper. All right, so I know that's a lot of good features that we went through. Next, I'm going to hand it over to Alex to talk about some of the use case and show you a live demo on how easy it is to achieve all this.
Awesome. Thank you, Yufi. So now let's talk about some common use cases for EFS. There'll be particular focus here on cost optimization because that's something that has really resonated with customers over the last 2 years and has driven a lot of our roadmap. First is kind of a broader set of, or a broader description of how our customers are using EFS. And frankly, our customers do everything on EFS, all the way from running complex global scale SaaS applications on the service, all the way to distributing configuration files to serverless applications or running their DevOps workflows on the service. And so there's a tremendous gamut of different kinds of workloads that are well suited for EFS. And here are some of the highlights or some of the more common commercial applications that run on the service as well. Next, we'll take a look at how EFS's cost-optimized storage classes have helped real customers reduce their storage costs. First is KubeRT, which is a quantitative asset management firm based in the UK. They use EFS to provide simple shared storage across their teams of hundreds of quant researchers. They were looking for ways to optimize costs without slowing down their mission-critical research workflows. Cube enabled lifecycle management to EFS IA and to EFS Archive, and they were able to reduce costs of running EFS by over 30%. And since tiering only affected colder, less frequently accessed data, they were able to achieve these savings without slowing down their end users or needing to do really anything operationally. Cube was able to move petabytes of data by simply clicking a checkbox and letting EFS do the work. Next, we have SAP. SAP uses EFS for shared file storage for their RISE with SAP software as a service solution, which they manage on behalf of their customers. I'm sure there's some people here who are users of this application. SAP, like Cube, we're looking for ways to optimize costs without affecting availability or application performance. They took advantage of EFS's cost optimization features, and they were able to reduce cost by leveraging EFS's colder storage classes for less frequently accessed data. They were able to save over 50% on their storage bill, and were able to move over 2 petabytes of data to colder storage classes, again, without needing to do any sort of complex application refactoring or mixing and matching of storage solutions, which was really, really nice to see. Last bit before we jump to the demo, I just wanted to kind of recap, because there was just so much information that we shared in the past 30 minutes or so, best practices or configurations for your EFS file system. This is effectively everything we're going to use in the demo moving in the next little bit, but I did want to kind of summarize in a single slide our service team recommendation for how to best optimize your file system, or rather where you should start with your file system configuration. All of these, except for utilizing the EFS Mount Helper client software and access point, come as default in the console. So you create a file system, you get 90% of the way with the EFS Mount Helper and your configuration of access points based on your architecture being the 2 things that you need to do to kind of get to that best practice that we recommend. So I just wanted to share this as a single slide, easier to digest or take a picture of before we moved on to the demo. Awesome. So let's kind of switch over to demo mode here. We were originally planning on sharing a video snippet of the demo, but we thought it was Thursday afternoon, and showing a video of a demo was really not that fun. So we decided to just move over to my personal laptop and just kind of run through it live. I was told that was a reckless move, but I still think it's going to be more exciting. Generally speaking, what we're going to be doing here, provide some context around the demo itself, is little user here on the bottom, I'm going to be connecting to the console. We're going to be creating an EFS file system, which will create the data structures in the EFS cluster, which is backed by tens of thousands of servers, and create some of the network routing configurations that will allow you to start landing data on EFS. Next, we're going to jump onto an EC2 instance, and we're going to start writing some data to that file system. The demo at a higher level is going to simulate, at least from an EFS perspective, a common analytics pattern that customers use. We have a single publisher of data, or a small number of publishers of data, and we have a very large number of consumers that are doing some sort of complicated analytics on the actual data stored on EFS. From a demo perspective and from an EFS perspective, what we're going to be showing here is exactly the same as customers who store petabytes of data and access EFS via thousands of instances, serverless functions, or containers. Obviously, what the compute will be doing here is going to be trivial or trite, but again, you can kind of use your imagination, take some of the complicated business logic that you have to work with on a daily basis, and place that into these functions and effectively try to play along and see how this might work for some of the business problems that you're trying to solve yourself. So let me swap over here to the demo setup. Just one moment. All right. Awesome. Hey, it worked. Exciting. All right, so the first thing we're going to do is go to the EFS console, and we're going to create our file system. If you hit the Customize button here, you'll basically see everything that was described in the previous slide pre-configured. But frankly, we don't need to do any of this because we can just go through the Quick Create wizard here, give the file system a name, and then hit Create. And that's going to start the process, which will take about a minute or so of creating those data structures on the EFS side and building some of those network routing layers or some of those network routing links on the AWS EC2 network. So while we wait, we're going to go and, again, touch on something else that Yuffie described earlier, which is an EFS access point. And we're going to need our EFS access point because we're going to use Lambda as part of our concurrency demonstration. So we're going to go and create a file, create an access point. We're going to call it Lambda. And for the purposes of this demo, we don't need to fill in any of these user, group, root directory creation, or root directory path, subdirectory configurations. But those are all available here, depending on what you're trying to do with the access point change itself. So we're going to go and create that. We can go back and check on our file system. Let's see how it's doing. I'm going to check the network tab, and we'll see that those mount targets are still creating. That's fine. Go hit our attach button here, and we're going to go grab our file system ID and our mount command prior to moving on to the EC2 console. And just to make this simple, we're going to connect to a running instance via the nifty web-based terminal, which, for the purposes of this demo, makes things very easy. We're going to wait for that to connect. And the first thing we're going to do is we're going to install EFS utils. On Amazon Linux, this is just available as an RPM in the Amazon, public AL repository. So we'll just go and do that. Hit yes, and let that finish. That's going to enable two features on the instance. One is encryption in transit. The link between the NFS client to EFS is now going to be encrypted. And it's also going to enable our 1.5 gigabytes per second per client throughput feature by allowing us to do multipathing to EFS from the client. So what we've installed here is a very small open source proxy that will basically multi-connect to our EFS mount target in a way that is more intelligent in the context of EFS than something like NFS N-Connect. So we'll go back to the EFS console. We'll go take a look at our mount targets. They're all fully available. Great. Go back to the terminal. We will paste our mount command. Will work. And then we'll go ahead and generate some data. And all this is, in the context of the demo, is DDing a bunch of zeros, 2 gigabytes of them, to the EFS mount point. And then what we're going to do is we're going to just run a simple Python script that the only thing it's doing is implementing concurrency on the file read so that we can fully saturate our ability to read this single random file, and we're going to run this. And effectively now we've, in a few commands, did what it would have what prior to EFS in the cloud would have taken months of work, procuring instances, configuring networking, building out a ton of infrastructure to basically get to the point of being able to get to this bottomless file system. Would have been a ton of work, and now we just were able to do this together in 2 or 3 minutes, which is a tremendous amount of time savings and provides you with a tremendous amount of agility in using file storage more generally. So what we see here is we read this file a bunch of times. We were able to hit our, pretty much the instance network bandwidth limit, get very close to that 1.5 gigabytes per second of throughput. And frankly, everything worked fine. And we're able to demonstrate here pretty quickly that we're getting up to speed and are able to reach EFS's optimal performance levels, again, without needing to configure or really do anything with any real complexity, which is great. So next, what we're going to do is we're going to swap on over to the Lambda console. I pre-provisioned a simple Lambda function. Its code is, again, super simple. It's just reading the file from a different path location this time, and we'll talk about this in a second. But again, use your imagination to do something more complicated that, again, fits into the business problems that you're facing. But the building blocks on the EFS side are exactly the same. So we'll go over to the configuration tab. We'll scroll down to the file systems configuration pane, and we're going to go ahead here and add our file system. And we're going to add our access point. And we're going to give this file system a local mount point in the Lambda container. STG344. Go and save that. That'll update the function on the Lambda side. And then we'll jump to the handy Cloud Shell here to run an AWS CLI command to instantiate a large number of these Lambdas. This, again, closely resembles what many of our customers do across a variety of compute platforms when they run these highly concurrent analytics jobs. And there we go. So we'll just run all of these Lambdas. They're all going to concurrently read the EFS file system. They're going to read data at a very high rate, tens of gigabytes per second. Again, no configuration, nothing needed to be done on the EFS side. Frankly, it just worked. And we can go ahead and here probably start seeing some of, we're starting to see some CloudWatch metrics coming out from this file system. Probably nothing super exciting because of we've only been running throughput for a few minutes. But basically, what we have here are all of the pieces you need in order to very quickly use EFS as a kind of fundamental building block to your applications. And again, just be able to really get to very good, very solid performance very quickly and very easily, which again will just make your lives easier as customers and allow you to work on solving real business problems that you're facing rather than messing with infrastructure. Thank you so much. We really appreciate you coming out. Yuffie and I will be hanging out for a few minutes after the talk. If you have any specific questions that you'd like answered about your use case, questions about EFS, just want to say hi. I would be happy to meet you. And again, thank you so much for attending and learning about the service.